My name is Naomi Yates, and the following is the Caltrans District 2 Guardrail Inventory project I was involved in from January to June of 2023. The project was undertaken in this 7-county region in Northern California as a tool to plan and budget for updating existing guardrails that do not satisfy the MASH 2019 safety standard for taller, stronger guardrail. There were 2 steps involved. From July 2022 until March 23, latitude, longitude, post mile, and various other attributes were recorded for the guardrails in the entire district. Data was collected using PathWeb, Caltrans' internal Street View interface featuring data from 2019. When I joined the team in January 2023, I began to bring over 40 spreadsheets containing 2,997 records of guardrail into ArcGIS Pro, from which I could publish data and maps in Caltrans ArcGIS Enterprise and prepare them for use on mobile devices in field maps. Spatial thinking, especially regarding linear referencing, was pivotal in designing the GIS data structure for the project, as well as in recoding the data for its intended use. Caltrans uses a linear referencing system called postmiles, which restart at every county line and always increase from south to north and west to east. After extensive reading about this system, I chose beginning and end points, ET1 and ET2, linearly referenced along postmile routes rather than line segments to define each guardrail. I stored attribute data for guardrails in ET1 attribute tables to simplify field data editing, with ET1 and ET2 points for each guardrail sharing a unique ID. I edited the Excel data to make ET1s first to traffic by subtracting down post mile from up post mile values for northbound and eastbound locations, and the reverse for southbound and westbound locations. Negative differences indicated switched ETs, which I then corrected. I also recoded incorrect side of the road data based on Caltrans norms I had read about, which defined left and right always from an up post mile facing perspective rather than a direction of traffic perspective. I made all non-median guardrails on highways and freeways right for northbound and eastbound routes and left for southbound and westbound routes. Accuracy in these attributions was vital for creating functional, unique guardrail IDs that would make sense during field verification. The Caltrans District 2 Guardrail Inventory project relied heavily on the specialized geospatial technology of Caltrans, much of which was developed by the Division of Research, Innovation, and System Information. They have developed linear referencing tools and resources for defining and communicating post miles, both in the GIS environment and for general use by planning, engineering, construction, and maintenance staff. One of these resources is a lightweight, downloadable Python application called the Postmile Translator, which accepts properly formatted CSV files of point locations defined by either coordinates, postmiles, or odometers as input, and returns tables of any or all of the matching data for points along the most current digital model of Caltrans routes. You can get coordinates, postmiles, or odometers. I used this tool extensively to geolocate ET2s, which usually did not have coordinate data collected in the original Excel sheets. Caltrans also has its own Esri postmile toolbar available as an add-in for ArcGIS Pro, with the postmile validation tool, which will create point features along Caltrans routes directly from properly formatted CSV files of latitudes and longitudes. It will also call up valid current postmile designations, which have prefixes and suffixes and can change over time. This allowed me to improve the accuracy of our postmile data, which, like side of the road data, was also used to make unique guardrail IDs that reflected reality for people in the field and agreed with other Caltrans data sources for people in the office. Another useful resource on the postmile toolbar were postmile and odometer route linear networks that could be added to ArcGIS Pro maps and used as input for the Locate on Route geoprocessing tool. These were invaluable when subsets of Guardrail records failed to generate output from the previously mentioned tools, as they could be used even by clicking in the map interface if necessary, enabling the geoprocessing of every Excel record. The interactive visualization platforms of Esri's ArcGIS Pro and ArcGIS Enterprise were the most important part of the Caltrans District 2 Guardrail Inventory project, as I interactively edited guardrails in ArcGIS Pro and published our data layers, maps, and apps for field verification and data dissemination. Geolocating guardrails accurately was an iterative process between the map interface and the tables during geolocating QA and QC. Often, the map view showed errors in the guardrail attributes that could not be found any other way, like overlapping or duplicate lengths of guardrail. And the maps could be used to verify the location of some guardrails against the imagery-based map provided by Esri. Field verification of the true and current state of guardrails was the heart of this project. The PathWeb data collected in Excel was already 3 years old, and wildfires, collisions, and construction would have changed things in the field. The field map interface with domain-driven pick lists for field workers made this process clear and standardized. The dashboard. The dashboard provided a way to supervise field data collection live from the office, allowing traffic safety staff to easily review data and photos collected, and see various stats of the field verification effort. The Experience Builder Guardrail search and download interface made an easy way for non-GIS traffic safety staff to generate maps and attribute tables of post-mile range or map-selected guardrails for compiling the reports they needed for their regular workflows. This gave them access to the developing data set and allowed them to tell the difference between records which were field verified and records that were based on the 2019 PathWeb information. This Guardrail inventory project is being presented by Caltrans District 2 to all of Caltrans in July 2023 as a viable in-house alternative to expensive third-party vendors that could save millions of taxpayer dollars. While I did most of the GIS work shown here, much credit goes to my fellow Caltrans employees. Traffic engineer David Alvarez for envisioning the project, GIS specialist Steve Ganger and Brendan Finn for initial GIS field definitions, and interns Janetta Lopez, Victoria Cox, and Cameron Cox for collecting Excel data and giving feedback after field verification. We are excited to see this project continue and perhaps become a model for other districts in our state. Thank you.